In this lecture, we're going to look at how to write formulas for ionic compounds. We're going to go over one specific approach that will mathematically work for any compound. Now, we're just going to be worrying about formula writing. We're not going to be worried at all about writing or naming compounds yet. That'll be part of what we do in class. But with writing formulas, this approach is going to work for any pair of ions that I give you. Okay, so remember, as you're watching this lecture, you should be completing your review packet. Now, there's a couple of things that we need to review just so that these things are nice and fresh in your mind. So first thing is, since we're writing formulas for ionic compounds, we need to review what is meant by an ion. So remember that an ion is an atom or a group of atoms that's carrying a positive or negative charge. And ions, there's two types. You can have a cation ion. A cation ion is the kind where the group of atoms or the atom are carrying a negative charge. Remember that these form when electrons are lost. Okay. And anions are negatively charged ions, and those form, remember, when electrons are gained. Okay. All right. So, and ions, we know, are going to come together to form compounds. A compound is a substance that contains two or more, and again, different elements that are combined in some kind of fixed proportion or fixed way. They're held together with some kind of chemical bond, and since we're talking about ionic compounds, we're just talking about ones that are held together with ionic bonds. Remember, there are the other kind of chemical bonds that we've talked about, covalent, polar covalent, and nonpolar covalent. Okay, now, the couple of things that you want to remember, the positive ion, so the cation is going to be a metal, or it's going to be the polyatomic ion ammonium. Now, you're going to understand why I had you memorize the formulas and charges for those 10 ions as we get into this unit. An anion will either be a nonmetal or any of the other polyatomic ions that I had you memorize. Now remember, there's a bunch of other polyatomic ions that I didn't ask you to commit to memory, and if I was having you make a compound with one of those, I would give you the formula and the charge. Okay, so remember that ionic compounds are formed when a cation and an anion combine because opposite charges attract. Okay. So if you take two positively charged ions, so if you have two cations and they're trying to combine, you're not going to get a compound. And same thing is going to happen if you tried to combine two negatively charged ions. So if you tried to combine two negatively charged ions, you're also not going to get an ionic compound. Now, two nonmetals can make a covalent bond. So two nonmetals can make a compound, but it won't be ionic. Okay. All right, so we're going to look at a couple of examples on the next slide. Okay, so on this slide, I'm going to give you a couple of examples of ionic compounds. Okay, just so that you can look at the parts of the chemical formula. So here's one that we've seen and used a lot, sodium chloride. There's the atomic symbol of the metal. Okay. And there's the atomic symbol of the nonmetal. Okay, and this is the format that they're always written in. The metal, then the nonmetal. Okay. Here's another example. K2S. Now when you look at this chemical formula, you see something else in it. You see this number 2 that sodium chloride wasn't in there. That number 2 is called a subscript, and it tells you how many atoms of the element written right before it you have. Okay, so what this compound tells me is I have 2 atoms of potassium combining with 1 atom of sulfur. And you should note that for the sodium, or in the sodium chloride, not the sodium, no subscripts equals 1 atom of that element. Okay, so if you were interpreting sodium chloride, it would be 1 atom of sodium is combined with 1 atom of chlorine. Okay, so this slide is finally getting into the how-tos of writing a chemical formula. The first thing that you're going to want to always make sure that you do is that you look up the charges of the elements involved on the periodic table, and I'll show you in class specifically where to find them, and you probably will figure it out as I'm going through some examples. Now remember that I did ask you to memorize some polyatomics, so you're expected to know those formulas and charges. And the approach that we're going to use to write chemical formulas involves using common multiples and recognizing what you need to get 2 ions to cancel each other out and add up to 0. Okay, so these are the steps that you're going to see me doing as I go through some examples on the next slide. I'm going to look up the charge, and I'm going to write it actually underneath the element or the ion. Okay. And I'm going to recognize, remember that the charges in an ionic compound have to add up to 0. So I've got to figure out, what do I have to get the positive charge to be and the negative charge to be to cancel each other out? And they're going to be a multiple of each other. And then you're going to figure out how many of that atom you need to get the sum to 0 by dividing that common multiple that you identified by the ionic charge. Okay, and that sounds kind of weird, and you'll see what I mean when I go through an example though. The answers that you get when you do that division are how many of that element or ion you need in the chemical formula. And those, remember, we'll use to represent, or will be represented with subscripts. Okay, so 2 pieces of key information. Remember that compounds are written the positive ion, then the negative ion, cation, anion, or metal, then nonmetal. Okay? Compounds have no charge. They're neutral. So when you see a chemical formula, there's no plus or minus signs in it. Okay, that's important to remember, because you are going to be using some plus and minus signs when you're figuring out what the chemical formula is. Okay, so we're going to write some chemical formulas. So the first place I'm going to go is to my periodic table, and I need to rewrite mine just because I can't see 100% of what I need to be able to see on my screen because of the program I'm using. So I go to my periodic table. Strontium is in group 2. Every element that's in group 2 has a +2 charge. Chlorine is in group 17, and when chlorine makes an anion, it's always going to be -1. So there's those two. There's the 2 ionic charges. Now, how do I get those to sum to 0? Well, to sum to 0, I need a +2 from the strontium and a -2 from the chlorine. So those are what I need. And the next thing I do, so I've written those down right here. Okay, divide each of them by the ionic charge. So strontiums will come down here, chlorines will come down here. Okay, and +2 divided by +2 is 1. -2 divided by -1 is 2. Okay, so that just tells me I need 1 strontium and 2 chlorines in my chemical formula. So this would be how I would write it, SrCl2. Okay. Now I'm going to do the same thing for the next compound, the magnesium and the sulfur. I go to the periodic table. Magnesium makes a +2, so I'm going to rewrite these again. Sulfur makes a -2. Those sum to 0 already. Okay. So I don't have to worry about a multiple in this one. So I'm going to take my +2 and my -2, divide each of them by the ionic charge. So this comes here, and I get 1 magnesium and 1 sulfur. So the formula, this is what the calculation just told me, 1 Mg and 1 S. So it would be MgS for the chemical formula. Okay, now, this next one's got one of those polyatomics in it. So we have Al and SO4. Okay, well, Al, go to my periodic table, it makes a +3. SO4 was one you were supposed to remember, it's -2. And to get those to sum to 0, you need a +6 and a -6. Okay, so I'm going to take +6 divided by +3 and get a 2, because that comes down there. -6 divided by -2, and I get a 3. So what this just told me is I need 2 ALs, and 3 SO4s. Now here's how we're going to write that. Al2, and I'm going to put the SO4 in parentheses because that shows, the parentheses show that those atoms are grouped together, and divide and put the subscript on the outside of the parentheses. Now the next one, K and O. I don't have a lot of space here, but K is +1, O is -2. Now to get those to sum to 0, I need it to be +2 and -2. Okay, so I've got to come over here. +2, -2. So for the K, I take the +2 and divide by +1, and I get 2. For the oxygen, I take the -2 and divide by the ionic charge, which is -2, and I get 1. So this just tells me I've got 2 Ks and 1 O. So the chemical formula would be K2O. Okay, so we're just continuing and doing the same thing again, and I'm going to do the bottom couple, and then I want you to try these up here. I want you to try those, that bunch right there, try on your own. Okay, but this one, NH4, is ammonium. It's one you were supposed to remember, +1, and phosphate has a -3 charge. So to get them to sum to 0, you need a +3 and a -3. Divide by the ionic charge. +3 divided by +1 is 3. -3 divided by -3 is 1. So you need 3 NH4s and 1 PO4. Okay, so here's how you're going to write that. Remember, you put the NH4 in parentheses, put the subscript on the outside. NH4, PO4. Okay. And the last one, the Ca and the P, I go to the periodic table. Calcium is in group 2, so it has a +2. Phosphorus is in group 15, and everything, all nonmetals in group 15 make a -3. So to sum to 0, I need +6 and I need -6. Okay. So take my +6 divided by +2 and I get a 3. -6 divided by -3, I get a 2. So this formula has 3 calciums and 2 phosphorus. So I would write it Ca3P2. Okay, now I'm going to give you the answers to these, but I'm not going to document it as much. Okay, so I do want you to try to kind of see how I came up with these formulas. So the chemical formula that you should get here is SrNO3 2. The one that you should get for NH4 and S is NH4 2S. And the one that you should get for Ca and CO3 is actually CaCO3. You might put the CO3 in parentheses, but you don't have to. Okay, so you're going to have some practice with this when you get to class the next time, and you'll be able to use this note packet as a resource.